Welcome, everybody. This is going to be a short presentation, shouldn't take more than about 20 minutes, on climate and climate trends in the Alberni Valley. So I did this not too long ago, about 10 years ago, for uh, an organization. I compiled data from my station as well as from stations in the Alberni Valley to look at temperature trends. Since then, I've compiled more data and coalesced a lot of the stations historically and come up with some nice graphs and things. So hopefully this is informative. I'll talk a little bit about personal weather stations as well, because that's always interesting and it's been more of top of mind for people, um, especially the hobby market of late. So hopefully you'll find this interesting. So let's get started. So the first thing I want to point out here, on the left is a map of all of the Environment Canada weather stations throughout history. So there have been weather stations from Environment Canada in Port Alberni since 1895. That was the Beaver Creek station. It started recording rainfall in 1895 in the fall, and it started recording temperature in 1900. So that's as far back as the record goes, and you can see there's a number of other ones. The yellow stations here are historic stations that are no longer functioning, and the green ones are still functioning. Although I believe perhaps Cox Lake is no longer functioning, but so we have a number, you can see, of different stations, and these were in various time periods. Beaver Creek was the first, along with Port Alberni early in the 1900s, and then Loopsy Coopsy and Redford um, were sort of next in the scheme of things. China Creek and the reservoir were very short-term stations. Robertson Creek is notable for being the longest period station. Now it took over from Beaver Creek. It's been active since the 1960s and still active today. So it has a very long period record. Some of the later years, this past 10 years or so, it's been a little on and off, but it seems to have gotten upgraded, and it's reliable again. So that's a great record that we have going all the way back to the 1960s. Port Alberni A was the station at the old airport on the Somas River. This will be familiar to people through the 60s, 70s, 80s. Um, and it stopped operating when they opened the new airport in the 1990s, and they put the new automated station there at that time. So the automated station at the airport is the official station of record for Port Alberni as of today, even though Robertson Creek and Cox Lake are also active. So that's the Environment Canada kind of picture. On the right side here, this is a map from Weather Underground. I tried to make it look fairly similar to the other map there, but these are stations, personal weather stations. So it's actually not all of them, because if you zoom into the Port Alberni area, you'll see a bunch more, but it's most of them. So you can see there's a whole bunch that are reporting today. They use various different types of hardware, and this is really a result of a keen interest. I think people have grown over the past 10, 20 years to see and record weather, and the simplicity and low cost to be able to do that. So you can get weather stations now quite easily. They're not very hard to set up. They connect to the internet really quickly, and they're not too expensive. So my next slide here, you'll see these are all of the stations, all of the personal weather stations in the valley by their codes, their airport or their weather underground codes. So there's a whole bunch of them. They're using various different types of hardware, but you'll see Davis Vantage here. I'm using the Davis Vantage system, as well as a number of others. That was really the standard up until this boom in weather, personal weather stations. So it's a little more expensive, starts around $1,000 and goes up from there, um, but very high quality, often used in agriculture. So it's a very reliable and well tested system. But the Accurite, the Ambient, the Logia, these are all widely available. The Ambients, I believe, are noted to be very accurate and very reliable, but all of these are very good. So they're easy to find now, easy to set up. Lots of people have them. So we have a really good opportunity to be able to gather good data. It's not all going to be perfect. Some people will have, you know, site issues with their temperature sensors or with their rain gauges. But for the main, uh, these stations produce fine data that we can bring into all sorts of data modeling or just trying to keep track of different local regions in our valley. So I might in time try to um, obtain some of the data from these stations and correlate them with similar areas from history in the Environment Canada records. So if any of these stations sort of line up a little bit, like mine does, this one down here, number 10, uh, that lines up pretty much exactly with the Redford station, which was at Redford School, which is just a block away from my house. So um, the weather conditions there should be pretty much identical to my house. So it would be really interesting to be able to correlate some of those. So I've created a gigantic spreadsheet, and don't worry, you're not expected to be able to see those numbers. This is just a little screenshot of the spreadsheets that I've created. I've collated all of the Environment Canada stations. So the blue is Beaver Creek, green is the City of Port Alberni station, the 1900s. Yellow is Lipsey-Cupsey by the paper mill. Orange is the Robertson Creek, which you can see starts in the 1960s and goes down to the bottom here to current day. Port Alberni A, SOMAS, is red here, so that's the station that was down at the old airport. Purple is the new airport station, the automated station, so you can see it starts right after the SOMAS one ends and continues to today. And then the gray is Redford and my station, so you can see the Redford station did not last long. It was only about 10 years that the Redford station was at the high school there. Um, but I've included that in the same columns as my own station, just to get an idea of perhaps historic weather in my immediate, very local place. So it'd be nice to be able to include a lot more of these personal weather stations that might correlate with the same locations um, in the Alberni Valley. So getting on to trends. So notable trends, I'm just going to pick out a few. I have all of the months, I have all the seasons, I have it by year, um, but there's actually not always a trend. So you're not always going to see a trend in the data. This isn't a mathematical thing. This is just being able to see a trend in the graphs. You can see each cross is a value from one of the stations. They're color coded by station. So you can see Beaver Creek, City of Port Alberni, Lipsey-Cupsey, and so on. And it just so happens they kind of move through the decades. So it creates a nice graph. But as in this case, so this is January maximum temperatures. So the maximum temperatures that are recorded in any January, you don't always see a trend in this data. This is pretty random stuff. Although Port Alberni SOMAS recorded 19 degrees. Is that SOMAS? Yep. No, sorry, that's Robertson Creek. Robertson Creek recorded 19 degrees in 2015. Is that true? Probably not. I think that's an outlier. You can see the other two stations, my station and the airport, recorded not quite 15 degrees. So that's probably an outlier. Um, but the rest of this year, there really isn't much of a trend to see. So we're not always going to see trends, but sometimes we will. So again, January, except this time, this is January minimum temperatures. So this is the extreme minimum temperatures that we would see or that we have seen since 1900 in Port Alberni through all of the stations. And here we can start to see a trend from around 1960 or 1970 up into the current day. So really it's that floor that we can see rising. And we can also start to see some outliers here as well. So this is from my station. 7.5 is the maximum minimum temperature. So that was the highest temperature that I've recorded in January for a minimum um, in that month. So that's very high. That's obviously higher. Here's the old Redford station. The highest it got to for a minimum was just under 1.5. Looks like 1 degree. So that's those two that happened twice in 2 years. Probably not an outlier. So that's pretty interesting. Um, that's sort of the first uh, trend that we see is a rise in January minimums. So probably meaning we're not going to see minus 20s anymore when we might see less snow for sure because we're just not getting down to those really cold temperatures. So next, again, minimums, but this is summer minimums. So this is for the whole season of summer, so the months of June, July, and August. And here, again, this is actually easier to see the trend because the minimums, the average, this is average minimums, so the average minimums through the month, they're quite tightly packed. So we can start to see that trend quite clearly. Even going as far back as the early 1900s, we can see a trend. So back in the early century, we were down at times, our average minimums were around 6 or maybe 7. Um, we haven't seen anything that low for a very long time, since about 1960. And we're now up, the average minimums in summer are now up around 10 or over 10, and even getting up over 13 at my station. So that's a concern. Those rising minimums in the summer can contribute to stress, not only for plants in drought, but for people. If it's not cooling off at night, and this is the average, right? So there's going to be higher minimums at night and lower minimums at night. But if that floor is rising, that stress on people is rising as well. So that's a real concern. Another notable trend, extending summers. So this is something that is very recent. So you can see at the very end of the graph here, we can see something has shifted, I believe. There's 2015. We can see that October mean temperatures. So this is the average temperature over the entire month is quite high, over 12 degrees. And again, this year it was over 12 degrees. Um, so that is quite unprecedented. There's a few here back in the 1930s. The 1930s is notable because there is a period of heat in the 1930s decade that often shows up. But I think we're seeing something different here, and we can see that it's been rising a little bit. You can see a bit of a rise there from the 70s into the 80s and 90s, and then it cools off a little bit, and now we're seeing maybe a step up again after the 2000s and the 2010s. So I have a real concern about whether this is our summer season, and which is also our dry season, extending through September and well into October. And that again is a real concern for vegetation as well as people. but especially for vegetation and also thinking wildfires and drought. So another notable trend, annual rain. So this is really difficult. Rain is probably the most difficult variable in Port Alberni to get a handle on. This is super random. I don't think that you can pull out a specific trend, except perhaps to say that is becoming more extreme. So I think we're seeing higher highs, lower lows at times. And we may be seeing a drop in overall uh, annual rain. So there's a bit of a peak here around the mid 1990s. That's the Robertson Creek station and the airport station. You can see it's quite high there, higher than anywhere else along the graph. But we haven't seen that. We haven't returned to that height since then. So it's been a good 30 years since we've seen anything over 2,500 millimeters of rain. So that's a concern. If we are seeing a drop off in the amount of rain we're getting every year, but I don't know if we can say that that's the trend at this point. I think rain is going to be very hit and miss year to year, and probably quite dependent on La Nina versus El Nino as well. And we are going probably into an El Nino in the coming winter next year. So that will be interesting to watch. But I would say maybe dropping, but probably becoming more extreme. So higher highs, lower lows, or perhaps just higher highs in very small events, short extreme events like we saw in November 2021 in BC. So another clear trend, I think, is annual maximum temperatures. So this is the highest temperature seen throughout the year. So basically the highest summer temperature. So I think we're seeing a pretty clear increase in that maximum temperature and what we can attain. We can see the heat dome here that set a new record for the highest temperature ever recorded in Port Alberni. Officially was 42.7, I believe it was. So that's the purple one. My station was just a little under that. But yeah, so that was 42.7. And of note, the Robertson Creek station did record 45.5. Now it's a little more exposed at Robertson Creek, so that's a concern. But I mean, the temperature is what you feel, and if you were standing in Robertson Creek at the fish hatchery, that's probably what you would have felt. So 45.5, that's extremely high, way far above anything in the history records we have here. The previous high was 41, I believe, 0.8, but we can see it there in the Beaver Creek record. But yeah, I think we're seeing a potential for very high temperatures, and I would not be surprised if we break 50 degrees Celsius within the next 10 to 15 years. I think we'll definitely get there at the current rate that things are going, and that's a real huge concern. So two more trends: annual average minimums. So this is the average minimum temperatures through the year. The floor is rising on this, so we can pretty clearly see that that both the bottom end here is rising from about 1960 on, as well as the top side. So this is all rising as well. So those minimum temperatures that we're seeing just aren't getting as low as they used to. You can see it used to be down. The average minimum back in the 40s and 50s was down around 1 degree, 2 degrees. That's low, and that contributes to things like snow and snowpack. We're not seeing that. We're up, you know, almost above our long-term average of of 4 degrees. So that's significant. And our minimums at Alberni weather have been very high for a number of years now, well above the historical record. There's the old Redford school. So we're a good degree to a degree and a half above the old Redford school at at the current time. So that's the end of our trends. So we're clearly seeing a rise in temperatures. And my last 3 slides here is all about what we can do about it. So number one, we must uh, end the use of fossil fuels and the burning of fossil fuels to stop the rise in greenhouse gas emissions. So CO2, methane, all of it. This has to go to zero. It can't go to net zero. It has to be zero. We can't emit any more carbon dioxide. Once it goes to zero, it will take 20 to 30 years to see that change in the atmosphere and see a stop in the warming. But until we make those changes, until we stop it, we'll simply get warmer. How do we adapt? You don't adapt to a moving target. You just can't. We have to stop it from moving first. We can adapt to the end state at that time. So to be able to say right now that we can take measures that will adapt to climate change, it's simply not true because we have not finished changing the climate. And that still is an open question, is how much we will have to adapt. We need to focus on stopping the change before we can adapt to our new climate. And lastly, how do we lessen the pain of global warming? So on the left here, these are all good things to do. And these are all things that I've been doing and I know many people have been doing all over the world and all, on Vancouver Island in Port Alberni for a really long time, but doing our best. We still have to do all of these things, but we're at the point now where it's clear the only way to make it stop and to truly improve our chances at, uh, you know, being able to adapt to something is for government to take the initiative like they did in the pandemic. At the beginning of the pandemic, say what you will about the rest of it, but at the beginning of the pandemic, when the emergency was on and they understood that they had to make major changes immediately, they did. And we can do that same thing with our economy and our whole way of life to stop the production of greenhouse gas emissions. So that is my message. Agitate for pandemic-like immediate government action.